Hello, it's Keith here, and this is lesson 16 of the simple series of my Z80 programming tutorials. In this series we look at a single source file each time that will do a common task that you might want to do, and today we're going to be making a simple example, which you can see here, which allows us to move a smiley face around the screen, and it can't go off the screen, so we've got some simple range checking going on here. And the idea is that if you were trying to build a game on this system and you needed somewhere to start with, a bit of input, a bit of graphics on the screen, then you could use this as a foundation. And because it's a single assembly file, if you're using a different assembler to me, hopefully it's going to be a bit easier for you to port to a different system. Of course, you can go to my website, you can download the source code, and you can also download the build scripts. So hopefully you'll be able to get started with this pretty easy. Anyway, let's get this off the screen and let's go over to the source code and let's start having a look at what we're dealing with today. Okay, so here is the source code for today's example. You can see we're starting our program here this is basically the entire program that you need. You just need to compile this to a tape, and as I say, I've got scripts on my website which will do that for you as well. Now, the code we're looking at today has a few different sections, primarily the reading routine. Now, the file is called CLX joystick, but that's just to maintain the naming convention with the other systems. We're actually reading in the cursor keys in this case. So we're reading in from the keyboard here, and then we're processing the keyboard directions and moving our player around accordingly. So this is the routine that's handling the player movement and the detection of the edges of the screen. We've got this routine, which we'll look at in a moment, for reading in the keyboard, and then we've got this routine for drawing our sprite to the screen, which we will also look at. And we've got two versions of our sprite. We've got the smiley here, which we use to draw the sprite, and then we've got an empty sprite here, which we use to remove it. So we just draw this over the top when the sprite moves, and we've got some variables here, which are the current position and the last position of the sprite. So those are what we're looking at. Now, reading from our keyboard is very easy. All we do is we read in from a variety of ports here, and we get various keys on the keyboard. And if we read in from port 80, we would get the 1 key in bit 0, the shift key in bit 3, up, down, escape and shift in bits 4 to 7. And if we want left and right, we have to read in from this port down here. So basically, we just specify a port and then read in the keys, and we just need to look at the respective bits that we're actually interested in. And that's what we're doing in our example code you will see today. So if we go over here, so basically we are using a 16-bit port, so we're loading B and C with the port address 0080 here, and then we're reading in a byte, and this gives these directions here, and these keys here rather, and we're basically shifting along until we get the up and down pair here, because those are what we want, and so we shift them into here and mask those, just keeping those bits here, and then we read in from 0980, which has the right and left keys here, so we are doing that again. And we're shifting these along until we get the right and left keys here, and then we're just setting all of the unused bits here so that all of the keys are now going to be 1 if they're not pressed and 0 if they're pressed down. So that's what we've done there. So that's how we read in our keys and convert them to a simple way of working. Now we use this up here, we use our read cursors, and then what we're doing is we're basically waiting until a key is pressed here. So if no keys are pressed, all the bits will be 1. So we just keep looping until something is pressed. When a key is pressed, we are going to back up the current position of the player, and that's so that we can restore it if the player tried to go off the screen. We're then running our blank player routine to remove the old sprite so that we take the old smiley position off. And then what we're doing is we're checking each bit, seeing if that bit is 0. And basically, if that direction isn't pressed, we're skipping over the next section. So what we're doing here is we're moving up 1 unit up the screen, so effectively 1 character block kind of size. Here we're moving down. Here we're moving left. We're moving 1 byte because each byte contains 8 pixels. So that's why we're moving 8 here and just 1 here. So that's the up, down, left and right. And then we save the new position here. So that's the new position the player's moved to. But what we do next is we check if the player has gone over the boundaries. Now the screen is 32 units wide, but if you go below 0, you will wrap round back to 255. So we're just checking 32 here, and if they've gone under the limit, they will end up with a higher value than that anyway. So if the player's gone above the 32 range of the width of the screen, or if the player's gone below the bottom of the screen, which is 256 minus 8, I don't know why that 192 is there, the 8 because the sprite is 8 pixels tall, then we are going to do a reset. And the way we reset is we just restore the old position of the sprite to the current position of the sprite. Once we've updated the sprite position, we're then just using the draw player routine to show the sprite to the screen, pausing for a little moment and jumping back to our loop here. So that's the loop that's handling the movement, processing the keys, affecting the sprite position accordingly, and then just checking if there's any problems with the sprite position and resetting the sprite if required. Okay, so how do we actually draw the sprite to the screen? Well, it's a little bit tricky on this system because of the way the memory banking works, but first thing we need to do is calculate the memory address that we want to draw the sprite to. This is fairly straightforward. Each line of the screen is 32 bytes wide. There are 3-bit planes because the system is 8 colors, but they're actually in separate areas. So each bit within it was the first bit plane. Each line is 32 bytes wide, so we multiply the Y position by 32 by shifting the bits accordingly until we've multiplied that up. We then add the X position because that's in bytes, and then we add the screen base, which is at A000. That's where the memory is going to start. So this calculates the position of our sprite in the first bit plane. Now we use this in our draw player routine. We've got a blank player routine as well, the only difference being the whether we're using the smiley sprite or the blank sprite to remove the sprite. In both cases, we calculate the memory address we need to write to, and then what we need to do is we need to page in the video memory. Now on the Camputers Lynx, there's a rather unfortunate thing that when we page in the video memory, if we do any writes to the memory at all, they will now go to VRAM and not to normal memory, and this means we can't use the stack when we page in video memory. So we're using shadow registers and things, and we can push and pop up here, but once we've paged in that video memory, we can't use the stack anymore. So it's just something to bear in mind if you try and tweak this code, which of course you're welcome to do so, and you should try and do so, but as I say, you need to understand the stack is out of play in this area. So we've calculated our VRAM destination, we've got our sprite source, we're then loading BC with FFFF here, and we'll need this in some places. And so what we do next is we are paging in the first VRAM bank, and we have to send 03 to port FF here, and then we have to send 28 to port 80 in hexadecimal here, and that will page in the first bank, and this is the red and the blue bank. These are both in this area. Now we use a single LDI command, and that will copy 1 byte from the source HL to the destination DE, and it will actually decrease the C value here, but we set that to FF, so that won't cause us any problems in this case. But we just need to reset that DE for a moment here, and the reason for that is we actually want to write to the same address in the next bit plane. Now the next bit plane is actually in the same bank, but the first bit plane is at the A000 range and the second one is at the C000 range. So we're just going to tweak the address we're writing to from A000 onwards to C000 onwards, and we do that by setting bit 6 and resetting bit 5 of the D register here, and then we write again, and this will effectively write the second byte from our source bitmap into our destination in the second bit plane. We then decrease D again, resetting the destination address because we now need to switch to the third bit plane, and we do that with a new set of out commands here. So this pages in the green component. There's actually 2 green bit planes, one you can switch between them for some reason, not very useful unless you want to have animation just in green, but you can do that anyway. So we page in the green bit plane, and we're writing again to the C000 range. That alternate green bit plane's in the A000 range, and we use LDI again, but this time we don't decrease DE because we do actually want to move to the next byte along the screen for if we were writing a multi-byte sprite, which we did do in the platform specific series. So we page in our green bit plane and we write the next byte again, and now we want to move down a line. Now our source address is in IY here, we backed it up here. So we add 32, which is the width of our screen, hexadecimal 20 that is. So that it moves us down a line. We then move that back into DE and we repeat for the next line. So we effectively jump all the way back up here and page in the first bit plane again and do all of that palaver again. Now this routine isn't the most efficient thing you could do for an 8x8 sprite, to be honest. I've got a tile example that's more efficient, but this is a more sort of generic one. It was based on the version I used for the Chibico bitmap, which was much wider. So if you wanted to modify this for a bigger sprite, you could do that. But anyway, as I say, this is sufficient for today's example. So that's what we've used, and that's what we used to get that smiley onto the screen. And you can see it again just here, and you can see we've got it checking, and it won't go off the screen no matter how far we try and force it. So there we go. So that's the example we're looking at today. As I say, you can go to my website and you can download the example, and maybe you can have some fun with it yourself, and you can also download the build scripts to help you get started. Anyway, that's all we're covering today. Now, if you're interested in Z80 programming and you want more information and you want to help support my channel, you can buy my book on Amazon now. It supports Z80, 6502, 68000, 8086 and ARM, and it's called Learn Multi-Platform Assembly with GB Akimas, like it says up there, and there's a link in the comments below. So if you want to have a look at that, go ahead. It's aimed at beginners, so hopefully you should be able to understand it. Anyway, if you've liked what you've seen, please hit the like button and subscribe, because if you like the videos, YouTube recommends them to more people, and if you subscribe, I feel super motivated to keep making more videos, which helps everyone out, so please do that. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.